If I just put it here, installation, instance creation, database creation, dbspace creation, chunk creation, we will see again today, dbspace creation, we will see again today. Physical logging, logical logging. Physical I covered it yesterday, but let me quickly repeat it today too. Today we'll see it. Right. Any topics, these might be looking like very small words on the top, but anything on there, so you guys okay. And, the other thing that I'll quickly cover is physical and logical storage structures today. Okay, I'll continue with where we left off yesterday on the physical logging, and I'll then start with logical logging. Now let me ask you this, Ravi. So what is your understanding on that physical logging that we discussed yesterday? Ravi Teja?
Yeah. Yeah, one moment.
Right, so
So,
what's your understanding on that physical logging?
so IDS will be basically having three procedures: physical logging, checkpoints, and fast recovery.
Right.
So in this physical logging, uh, we have, I mean, I haven't reviewed the status
Right.
thing.
No, that's fine, man. So it takes some time, right? So I'm just asking. Okay, now let me go through Shankar. Shankar, what is your understanding on physical logging?
Physical logging is nothing but physical storage. It will store the whatever the images before updating anything to the database. It will store whatever the updating we are going to do, prior images before the updating.
Yeah. The important point there is prior image. Yeah, now another question, follow-up question. Why do I have to store prior image?
Uh, we need to have the tracking, right? Everything we need to have it, right? Transaction details, everything. Prior images means like if anybody asks us like before how it will be before updating anything in database,
Mm-hmm.
we need to maintain some documentation or something like that.
No, 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 no. So can you guys, any one of you explain me what happens if I am trying to update a record in the table?
Update in your
Yeah, when I am trying to update a record in a table, what is exactly going to
oh,
happen?
So when we are doing any transactions, if you need any rollback,
Right, that's the point. That's the point. Now let me open a notepad here, the same notepad. Now it's the same example like we covered, we took it yesterday. So the same salary example. I have a salary table, I have employee ID, employee name, employee salary. So I have decided to run an update statement here. As a HR, update salary, set employee salary equal to 12,000, where employee ID equal to 501. Now what happens from the back end, right? What do? Is we just log in. So this is the thing. Now let me show you it here. Ideally, it's not recommended to create any database in SysMaster. Sorry, to create any tables in SysMaster, but just I'm just doing it right now quickly to show this example. Under the query language, so these are the three lines I'm creating. One is I'm creating a salary table, inserting into salary. Right. Now when I say, the next thing what I do here is when I say select star from salary, I got two records. Now what I'm doing it here is I'm trying to update this. Now this is a statement I'm running. If I click on run, what happens in the backend? What happens in the backend? Now if I open it on another session here, here I am connected to the database, right, SysMaster. So the moment I connect to the database, there is a background thread created. How can I see that thread? You can run a command called onstat space -u to see all user level threads. All user level threads it will show. So here all the user level threads and what are the respective users started. Each thread will open a session, a successful session. Session is nothing but a connection with the database server. So one of these is responsible for this DB access here. Someone connected to the database here. This is identified by one of these sessions, right? I don't know which session that is. So if you look at this, this is the thread ID. What is the thread currently doing, which is specified by flags. The current session ID, which is needed to find out the current SQL or current work each session is doing. Informix, this is the user. the terminal, from what terminal, each Unix terminal, for example, whenever I open any new terminal, each terminal has a terminal ID. Whenever I say TTY, each one has a terminal ID. This is a terminal ID too. If for example I issue a command dbaccess sysmaster, so if I run this onstat space -u, U stands for show me all the user threads, right? You see I got a terminal ID 2 here, right? So similarly, is it waiting on something? What is the current timeout? Number of logs it held, number of reads it does so far, number of writes it has done so. All this information it shows. Now let me find out what is a thread associated with our update statement. Now here I am suspecting this is the one, see, because there is no easy way to find it out when I have number of sessions like this. Now if I exit the new one and if I run it on stat space -u, I am seeing only value at this TTY. Probably I am suspecting this is the one, right? When I use another command called onstat -g SQL and enter, show me list of all the SQLs that my sessions are running. Onstat space -g SQL, right? Remember these commands because these are very important in a troubleshooting. Onstat -u, it will show me all the user sessions, right? The important thing is you get a session ID. Then onstat -g se SQL, it will show the SQL the session is running. Okay. Now when I say onstat -g SQL, these are all the sessions which are currently running any SQL statement, right? Now it shows what is the current database here. Now what is the database we have connected here? Sysmaster. There is only one line which is associated with sysmaster, right? You can also exactly find it out by using onstat -g ses or SQL and just give session ID. When you just pass the session ID, it will give the respective information about that session. You remember this was the last statement we have run because we haven't run the update statement yet. What was the last statement we have run in this session? Select star from salary, right? So that's exactly the session ID here too. Terminal ID 032. I suspected this, but to be sure, 32. And we can also get a further details about this session using onstat -g ses 32 and enter. So when you see this onstat -g ses 32, it shows further details about the session. The important details are what is the program it is running, what is the process ID, from which host it is initiated, and what is the current condition. All this information about that session that is useful. Three important commands. Session ID, onstat -g ses or onstat -g ses, you can specify session ID. If you look at this command called onstat is a very safe command to run anytime. Because onstat onstat does only reads. It does only reads. It will never perform any writes on a shared memory. What it does is whenever you run with any flag, it will go and get the respective information from memory. It won't write any changes. It's very safe. Even you can run this blindly, right? You can run just this blindly. Any questions so far? Yeah, that's a very good question. Where this information is stored, right? Because
Yeah.
when I say now onstat space minus u, I got 23 active sessions, which includes background sessions, which includes user sessions. If I make another connection now, I'll see 24. Now, where this information is stored in the sysmaster database. In the sysmaster database, DB access, when you say sysmaster, you will go and connect to sysmaster database. Here you can see database under instance. You go to tables, info, sorry, not order, info. These are all the tables. One of these tables you have it. One of these tables you have this information stored, but they are not permanent, right? They are not permanent. They will change. One example is when you say onstat-p. When you say onstat minus p, it will show the profile information. The profile information is number of disk reads you have done from the past 12 minutes. From the system that is up, number of page reads you have done, percentage of cached reads, percentage of cached writes, information like that. You see what I'm saying? Right. So if I reboot it, everything will be 0. We had so far these many log requests. Oh, that's so huge from the 12 minutes. We have these many checkpoints. So far 0 checkpoints happened. 0 deadlocks happened. Buffer weights 33. So these are all the important things. So far these many commits happened. Right? When someone gives me a new Informix environment and says that, okay, can you please see if there is any opportunity for performance tuning? This is one of the first commands I will type. I simply say onstat space minus p, right? Then it shows me that how is the system performing. The first important metrics are percentage read cached and percentage write cached. How much we are getting from buffer cache. We will talk about that in tuning. This is one of the important tools. Right, to answer your question, it gets stored under sysmaster. It is stored in the sys shared memory itself. They are shared memory structures, so you can just get it through sysmaster views, but they are just transient. They are not permanent. Right. Now coming back to our question of updating. Right. Now what is going to happen here? I created a table. I inserted some data. Now I am updating it. Right. Now what exactly happens is you need to understand there are two types of storages we have. One is I have a physical memory or a RAM, right? Another one is I have hard disk. right? This is my physical memory, right? This is my physical. This is my physical disk. This is my RAM, right? There is a concept here called a page. It is like page, book pages. When we were studying, we used notebooks to write information, right? So these page sizes can be uniform, or these page sizes can be multiples of your default page size. What is the default page size in Informix? 2 KB, right? We can have these page sizes of 2 KB, or we can have it multiples of 2 KB. That's 4 KB, 8 KB, 16 KB, right? Whenever I create any table and insert some data into it, they will go and sit in one of these pages in the physical disk. They will go and sit in one of the pages in the physical disk. See what I'm saying? Now let's say we have our record stored here, and I have some page number associated with it. I mean, that's not relevant, that's not needed here. So whenever you run this update statement, whenever user runs this update statement, we are talking about a session ID, right? There is an SID. This guy is responsible for delivering your work. Now what this SID, let's say, what is our session ID here? What is our session ID here? Our session ID is 32. Now this session ID is responsible for performing your update. Now what this session ID does here is, it searches for required data. What is the required data? The condition that is meeting employee ID equal to 501 in this RAM here. Even in RAM, main memory, the data is stored in the form of blocks only. So like this, it fills all the blocks, right? You see this SID, the SID 32 is responsible for checking your data. Now it checks if any of these blocks are pages. In short, we call it as a page, the terminology. Oracle calls it as a block. Doesn't matter, right? Page or a block. Oracle checks for all these pages in the physical memory, right? For these record matches. If it finds what it does here is, on the other side you have something called physical memory as well. So physical memory, you have like this. This is your physical disk. That's called physical logging disk. Now what I put it here is, right, this is also storing the data in the form of pages only. Now let's say let's say Informix server finds, this session ID finds the data here, because prior you read, or prior Ravi updated this table, someone read the same records, so that's why they moved data from here to here. So now before it modifies data in this page, what it does here is, it copies the data here to here. the image, prior image, before it modifies. Now, so that you have a safer copy here, right? Now it updates this data. Now once you update this data, there is no guarantee that you are going to commit. There is a concept in ANSI standard that I can open a transaction, I can do DML or DML operations, I can roll back. The concept of rollback is you can go back, right? So here, once I update it, it's by default committed. I will show you that type of a databases where you have a logging concept, log, L-O-G, right? But there is a concept that once I update, I need to validate if my update is correct, then I will commit. If I commit, it's very good. What if I roll back? Right? If I roll back, I need a prior image. So that prior images are stored here, the physical logs. Just in case if I don't find my record, original record here, I will read the record from here to here. This is called doing an IO. This is nothing but doing a read. Reading from hard disk to memory. This is a most important concept because it doesn't matter whether you are in Informix or Oracle or DB2, it's a similar concept. If you are able to find it in a memory, right, probably your update statement finishes up in like maybe 0.2 millisecond. But if you are reading it from disk, your update statement might complete in 0.8 millisecond. Why when I read it from disk it takes longer time? Because disk is the slowest part, right? If you look at your laptop configurations, ask yourself what is your laptop configuration? You say 8 GB RAM and you say 1 terabyte hard disk. Why can't you have 1 terabyte RAM, right? Why aren't we having 1 terabyte RAM? Because this main memory is costly. Why it is costly? Because it's super fast, right? If you are a super smart guy, you charge like $100, $200 per hour, right? Why would you work for $15, $20 or $30, $40, right? Same thing. I mean, this is just quality memory, quality storage. So that's why it's used for memory. That's why the remaining stuff is used just for storage. So that's why whenever we read it from storage to main memory, it is called as one IO, doing one IO when I read this one page. If my data that I am trying to look for to update or a select statement or whatever the statement is in more than one block, I have to read other data as well here into other block. Then I am doing two IOs, two reads. IO stands for input, output. Then I will be doing two reads, right? You see what I am saying? Right. Now once I am done with my work, right? Now here comes the important question. Let's say I updated this here. If I press escape and run it, one row is updated. If I say select star from salary, I see the updated value for Raviteza. I see updated value for Raviteza. Right? Now, when I run this select statement again, or if I open a duplicate session, and if I run the select statement again, it is going to get the data for your query from memory. this memory is of some size. If you go if you go and look at on configuration file, there is a parameter called buffers, right? We will talk about that in the configuration section. But at a high level, this is a fixed size. Probably I have decided here to have 100 GB as my RAM. So you can store somewhere like 40-50 GB of data here itself. That is most frequently accessed data will be here. If you studied something in engineering called, there is something called LRU. Least recently used data will be flushed out from this main memory to disk on a regular basis, right? When I keep doing queries on salaries, it's pretty high chance that I can find the respective pages here only in the memory. So if I'm somehow running a query that some new table that select star from the table that I never used are very rarely used by other users as well. It's not just me running the query most frequently. Sometimes in an organization, from an application side, maybe there are top 10 tables or 20 tables that are frequently accessed. Our database servers are intelligent enough to keep such kind of a tables hot blocks. They are called as hot blocks. Hot pages. Such kind of hot pages are by default kept it in memory till the extent it is possible. So that whenever someone is reading the salary table, the data directly comes from memory so that it comes in 0.2 millisecond instead of 0.8 millisecond. But there is an important point. How longer the data in memory is kept like this? Till till this block is needed by some other highly used processor or a new guy, right? Or there is a periodic concept here called checkpoint. There is a periodic concept here called checkpoint. This checkpoint happens by default in Informix in a 5-minute interval. So the checkpoint is nothing but whenever I modify this page is called as a dirty page. Dirty page. The page is called as a dirty page. Dirty page is nothing but you read this page from a disk, but the page got modified. But this page was not updated back in a physical disk. So even though your page is dirty, if let's say Raviteja is coming and running a query, the data comes from this page only, instead of you going from a disk. Now this dirty pages needs to be consistently flushed to physical disk. That flushing process happens through a concept called checkpoint. Checkpoint. This checkpoint is by default 300 seconds. Happens in a 300-second interval, or you can manually push for a checkpoint too. Any questions so far? This is nothing to do with Informix. You go to any database server, I recommend you to go back to this recording again. The concept is same. You have a physical storage, which is the cheapest one. You have a physical memory, which is the costly one. So that's why we talk about 100, 4 gig or 5 gig or 6, 7, 8 gigs. But when coming to hard disk, we talk about terabytes. Because the 1 terabyte probably like 2,000 bucks, 3,000 bucks, right? So here it's hardly like, physical memory is so costly. Now whenever you cannot find something in the physical memory, you will go and read it from physical disk here. So the minimum you can read is only page. The minimum IO you can do is only page, right? Even though you are looking for only one record, you cannot get one row from here to here. You have to read entire page from here to here. Some databases call it as a block. Once you modify it here, I mean, before you modify, you keep a prior image here. That's called physical logging. Physical logging. Right? Now, the concept here is the moment you modify the block and you commit the data, you don't immediately write it into the physical block here on the disk. You don't write immediately. Take that point. Why you don't write immediately? Because writing like this is a performance intensive operation. There are like millions of blocks changing at any point in time. You can't keep writing millions at a single shot. No. I mean, you can't write it every time, every second, every split second. So that's why there is a concept called checkpoint. For every 5-minute interval, it writes it into this, and all pages will be flushed one time to respect to chunks, data files, or db spaces. Any questions till this point? Now let me ask you this question. My block is here. I committed. Now all of a sudden my system crashed. And when I'm trying to run, what I'm saying is I updated, right? The checkpoint did not happen. Somehow the system got crashed. Once it is down, right? During this interval, let's say what I'm saying here is I have done this at 8:33. The checkpoint is scheduled at 8:38. But somehow in middle the crash happened. Crash happened in such a way that my system is down. When I'm trying to do on it minus v, it's not coming back online. It will come back here, but when I'm trying to do, it's not coming back online. Now what are the options I have left out? Right? There is a concept called instance recovery and media recovery. When I have an inappropriate shutdown without doing a checkpoint, it carries instance recovery. Right? Because see, the point is whenever I do a shutdown, the data in this is gone. Whenever I do a shutdown, the data in this memory is gone. But the important point here is we have unflushed data here. Now what happens to this unflushed data when this data is gone? You see what I'm saying? I'm saying that we do all the operations in memory. That's very good. It's a speed. Very nice. But before we do the checkpoint, that is flushing this data permanently to store it in data files or chunks here, we had a crash. Yes, we are in the middle of like 300-minute interval, but the crash happened. Now we have to do a media recovery. That means we have to get it from physical files. But this data is not stored here. Right? Are we going to lose it? Lose this transaction because the data is not flushed? Your user is not going to like it if you say you lost a transaction that is committed. That's not databases as with properties. The D says that the transaction should be durable. Once you commit, it's committed. For that reason, what do we maintain is we maintain a separate copy here called logical logging. There is a concept called logical logs. Whenever you do any TTL or DML, the data is immediately written into these logical logs. Before you flush this data here, right? So the data from here, whatever is the page modified here, will be coming from here to one of these pages on the logical logs. This is also an physical storage only. This is not a memory. Logical logs. Now, if there is any media recovery needed, right? You restore the physical logs here. The respective changes in the memory which are committed are available here. Right? So yesterday what we looked at was, in the last session we looked at about physical logging. By default I explained that these two are stored, physical logs and logical logs, in your root DBS. There is a concept called root DB. This is the place where your initial sysmaster database gets stored. How you can see that information? When you say onstat space -d, you have this root DB space, which has one chunk so far, and the chunk name is this one. When you say oncheck space -pe and give the chunk name, you can see the disk layout. What's happening? Sorry, it's a DB space. When I give root DBS, it says that this is a chunk name, first chunk name, and this is how the disk layout. By default, these prior images and the committed or uncommitted changes, which are part of physical logging and logical log, are stored as part of your root DB space. It was free here because yesterday we moved it. So, but still you have your logical logs, 6 logical logs or 12 logical logs like that. So today I'll be moving these logical logs to its own DB space. For performance reasons, these are every second written heavily, prior images and modified pages. So for performance reasons, Informix advises us to move them to separate DB space. That's why yesterday in the last session we created a physical DBS and we moved physical logs here. Now what I'll be showing you here is how do we move these logical logs. How do we move these logical logs? Before I go and explain that, are we clear on this? Are we clear on these boxes? What are all the entities involved here? Now at a high level, what I spoke here is the physical memory, hard disk. So if I just put it here, physical memory or RAM, hard disk, page is a default storage, basic minimum storage you get. We spoke about something called IO, right? Then we spoke about dirty page. We spoke about checkpoint. The interval is 300 seconds default. You can see it like this. It's in the configuration file with checkpoint interval. Then we spoke about physical logging, prior pages, logical logging, committed or uncommitted changes. Right? There is something called instance recovery. There is something called media recovery. For instance recovery, in case of a crash, you don't have to do anything. You just have to start. System will take care of automatically. But if there is a media recovery needed, that means from your backups you have to restore, right? This is a difficult thing. This is an crucial thing. What else we spoke here? Right. So the whole concept of these logical logs is you are not going to lose any transaction that is committed. Right? It's like you went into a bank and you withdraw $10,000 and all of a sudden it says that your transaction is not successful even though it dispatched $10,000. It's good for you. You got a money, right? But it's not good for bank. So anything that you committed should be there. Anything which is not committed should not be there, even in case of a system failures. So you went into an ATM or you are in the process of withdrawing like $100. You entered everything. It's about to dispatch, but system got crashed. Your money should be safe, right? Your money should be safe. Right. That's the concept. All right. Now, this is all needed if you are getting into like performance tuning, and probably people ask you, do you have experience in performance tuning? What kind of a performance tuning you have done? Can you explain me? Why do I need a physical log, prior image? Why do we keep prior image? You can do update on this block number of times, right? When you are rolling back, it quickly comes here and gets this prior image.
Ravi?
Yes, Raviteja.
Yeah, so the logs in the physical logging will be stored in physical drive or RAM?
They are stored in the drive.
Okay.
That's wherever we are defining this. This is the drive.
So the physical logs after committing, it will vanish in the physical drive or it will stored.
Yeah, the question you need to ask there is these pages, the files will be there. This is the physical file. For physical DBS, this is a chunk.
Okay.
These chunks will be there, but that's a very good question. So what happens to this block after I commit this? After every checkpoint interval, this becomes invalid. They can be used it for something else.
Okay.
Checkpoint is nothing but, let's say you are going into an unknown place, for example, trekking. You put post, right, saying that, okay, so I can safely come back to this point. Okay, from this point, okay, let me explore this route. Okay, this is not a good route. Let me come back. Let me go in the other route. Checkpoint is that kind of flag post. Till that point, you are safe. Entire system level I'm talking about. When I'm talking about a commit for an individual user, that user is safe till that point. Checkpoint is at a broader level, commit is at an individual user level. Right. Shankar, you are okay too?
Yeah, I'm okay.
Now what I do here is, I will move these transactional logs. When I say on check -pe root dbs more, I will move these logical logs from here to a different db space. Let me go ahead and create its own db space.
Ravi, another question.
Please go ahead.
So yeah, in the physical list, after the commit, it will be writing, or after the checkpoint, then it will be writing in the physical list, physical drive.
You mean physical log, right? Here
Yeah.
or here?
Yes.
Here before you start, the moment you read something from here to here and you are trying to modify a block, right? That right, it's here. It writes here prior image. Whenever you do any change, it writes it here. The change details are available here as well as here. You got that, or you want me to explain again? Ravi? Now I am beginning a transaction. Now I said update salary, set salary, employee salary to 14,000, where employee ID equal to 502. Now before I update this, the prior image is kept in. Before executing this update statement, the prior image is kept in physical logs, right? So I did not commit it yet. Before I commit or roll back, I can do other update here. Right? I can do update multiple times, right? So updating to 14,000, updating to 13,000, right? But the prior image will have the result as 12,000. The prior salary of employee ID 502 before it starts the transaction is 10,000. The physical log has only prior image. You can do update multiple times, but still the prior image is 10,000. But whenever you do update from 10,000 to 14,000, and from 14,000 again to 13,000, yeah, from 14,000 to 13,000, all these changes, every change is written into logical log. Whether you commit or roll back in future doesn't matter. All these changes written into these logical logs, which we are also calling as transactional logs. Transactional.
So Ravi, my question is, when we are doing the checkpoint, so after 300 seconds, it will be writing in the root dbs, the physical drive. So when we are doing the commit, will it will be writing in the physical disk again in root dbs?
It won't. It won't. It will only write it in logical logs. It won't. Commit
So
happens
only in
back
the root
here.
dbs after the checkpoint, it will be writing.
The
So after the commit,
commit, it won't. It won't. The data is
okay.
committed and that information is available in logical logs. Root dbspace or the respective dbspace has no idea whether that page is committed or not. Only
Okay.
checkpoint flushes these committed or modified pages from here to here. Alright. Now let's get back here saying that how do I move these logical logs from here to physical storage. Now here is the process. Now how do I list these logical logs? When I say on stat space minus L, it will show me list of logical files. I have 12 logical logs here, 12 active. But all these 12 have certain options here. U stands for used, B stands for it's already backed up, Each log file has a number. Each log file has some size, how much is used. So I can reuse them, I can use them in a circular fashion. Right. My point is I will remove all of them, and I will, because all these are right now in rootdb space. So for removing them, what I use is I use on params, on params with an option -d. When I say -log 12, 12th log will be removed. Now there is no 12th log. The 11th one will be removed, 10th one will be removed, 9th one will be removed. If you say on stat -l, I have only 8 logs right now. I got only 4 logs. Now when I'm trying to this 4th log, where did I get these numbers here? Each log has a number here. When I'm trying to delete the 4th one, it says that you cannot delete it because the log file is in use. You see here, this is where the current committed transaction, and this is where my last checkpoint is here. You should not have these C or L flags to delete it. You should have a B flag, and you should not be having the C and L. Now what I do at this point is I will go ahead and create a new table space. For creating a new table space, what I do here is, creating a new DB space, what I do here is, I will touch a file here, touch logs logdbs.1. Right? Now what I do here is the standard procedure. I'm just adding, I'm creating a new DB space with log DB space with a physical size. In the chunk location, offset is 0, size is, let's say, 20,000, or let's say 40,000. Now it will go ahead and add this new DB space. Now what I do here is I use on params command with the -a option with -d log dbs with size 2000. Now the 5th log file added, which is with a flag called a. Now like this I will go ahead and add few more log files. The log files will get a subsequent numbers 5, 6, 7, 8 and 9. Now if you look at these 5 logs are occupying space from log dbs. Here the size is reduced. These 5 logs whichever I have added newly, they are occupying space in this new DB space. But I still have old log files here, the 4 log files. That's why when you say on check -pe, root dbs and more, you still see these 4 log files. But if we do, the remaining entries are free because remaining 4 are already deleted. So far out of 12, I deleted only 8. So for 8 the space is free, it's showing. But here the space is still occupied for these logical log files. Now how do I remove them? Same process. On params -d -l 1, yes, 2, yes, delete 3, yes. But the challenge comes when I am deleting 4 because it says that log file is in use. Yes, this is in a used state. This is the current commit, last commit happened here. The last checkpoint happened here. So when it is in these states, I cannot delete this transactional log. Now what I have to use is I have to move the transaction log position from here to here. How do I do that? When I say on mode space -l, the checkpoint moves from here to here. I mean it's not checkpoint, the commit, the current commit, the log file switch happens. But still I have here L. So let's say on mode -c. Let me run the checkpoint manually. When I do this, everything will be moved to 5. Now at this position I can go ahead and remove this log file. Right? Now 5, from starting from 5, 6, 7, 8, these are all part of my new DB space called log dbs. Now in detail what I am doing here is remove existing, sorry, before removing you can add new db space as log dbs. You add new log files using on params -a command. Delete old log files which are located in rootdbs. How do you remove? Again on params -d -l option. So sometimes it won't allow you if we have a flag called u or c or l. So it's important to say on mode -l, on mode -c. This is checkpoint, manual checkpoint. This is switching or moving to next log file, transactional log file. Got it? Now if I go ahead and see here on stat -l, I got 5 log files, but all 5 are not part of rootdbs right now. All these 5 log files are not part of rootdbs. You can confirm it on check -p rootdbs. Show me the physical layout of rootdbs. Right? So you can't see anything here which is related to physical logs or logical logs. I can press the next space, but still you cannot see anything because that's covered under this free part here. Now what we have done so far is yesterday in the last session we moved it to its own DB space. Now I moved logs DB space to its own DB space. During the setup of an instance, a new instance, it is an important measure for production systems. Non-productions you can leave them as it is in the root DB space, but for production instances at least we need to move them to different DB space. So that's exactly the process I have detailed here. So we'll create a new DB space, drop the existing log files. If needed, we might have to move to next log, or we might have to say next checkpoint. Right. And this is to add a log files. Here is various log file status flags. A stands for log file is just added. D is dropped, but a backup is needed. F, it is free and available for use. U is used, and so whenever you have this U, or whenever you have this B, I'm sorry, L or C, it won't allow you to drop that log file. UCL won't allow. Right. Any questions so far? Any questions so far?